Hello, welcome to this presentation. I'm Miguel Ángel Ajo from Red Hat. I'm a senior principal software engineer, and today we'll be talking about Submariner, an open source project between Rancher and Red Hat, and how can we help you with your edge use cases. So just to give you an overview of the presentation, we will be describing what Submariner is, the use cases, the benefits, how service discovery works in Submariner, and how to install Submariner. Then we will be doing a small demo to show you how it works. So yeah, to start with, here we have a typical Kubernetes operator. He's very happy about it. Kubernetes is great. But then he has to manage multiple clusters. That's fine, but the connectivity between the clusters is not that easy, especially if you don't want to be exposing your traffic over the internet, opening ports, or creating public API endpoints for your applications. He really wants to make that simple for all the users of those clusters. So with Submariner, he can handle that need and create a simple network between all the clusters that he's managing. So Submariner, as explained, enables direct connectivity between your clusters, exposes a set of custom resources to describe the different things related to multi-cluster connectivity, like clusters, endpoints, service exports, service imports. It's a completely open source project, vendor net neutral. Rancher started this project, and then Red Hat joined, and there are a few other companies joining us lately to improve Submariner and open new possibilities. It is very easy to deploy with the help of an operator, Helm, and we even have a command line utility to help you deploy Submariner on your clusters. Common use cases are especially edge clusters. You can see, I have a small picture here, but yeah, edge use cases are infinite. In this case, I'm showing like multiple shops connected to a company central cluster, and every shop, every final location has his own edge Kubernetes cluster that connects to the company core cluster, where maybe some of the databases or central APIs for the company exist. And yeah, so it's a completely distributed environment. Another applications are availability, disaster recovery, and yeah, sometimes you need to comply with legislation of where your data lives. So those are pretty common use cases for Submariner. There are many other. Let me explain you how networking works with Submariner. Let's see first how it works for just one cluster. In one cluster, you have your pods, and you have the IP addresses for your pod. They can communicate to each other. They can communicate to services. They can discover each other and the services, use load balancing, network policies, and so on. When you have two clusters with Submariner, this pod IP networking becomes a flat network, unless your clusters have overlapping IPs, but we have solutions for that. And then again, the service discovery and load balancing is happening across all the clusters. Then we have plans to incorporate network policy, because of course that becomes increasingly important in this type of environment. We have proofs of concept for that, and we will be implementing support for network policy in the following releases. So the benefits of using Submariner are the ability to have direct east-west pod-to-pod or pod-to-service communication. Works with almost any Kubernetes cluster and is compatible with different network plugins. We are working to make it compatible with more network plugins, with more Kubernetes flavors. To make it as widely usable as possible. With Submariner, you can deploy services across multiple clusters and then access those services from anywhere, thanks to service discovery. And of course, all the traffic between your clusters is encrypted on the border. You can use IPsec or WireGuard. We use IPsec by default. And the design is open, so anybody could come and create a new cable driver using any technology. Even in some cases, no encryption is desirable, because maybe you don't want to you don't need the overhead of encryption. So this is a typical Submariner scenario, and so in the components, in this case, we have two clusters, cluster A and cluster B. Then we have broker, that it's just a Kubernetes cluster that we use as our central data store to share information about clusters, endpoints for connectivity with IPsec, WireGuard, whatever, and information for service discovery and so on. So we have that central component, which is the broker. Actually, in this drawing, we have an independent broker, but it could be any of the existing clusters. If you will be having lots of clusters, ideally, it's better to have a broker just for a cluster just for the broker. So about the network connectivity, okay. In this drawing, you can also see a few of the components deployed by Submariner. You will see that we have the gateway engine, which lives on the border of your clusters, and it will create connectivity to the other clusters, in this case in the form of IPsec. Then we have the route agent that runs as a daemon set on every node of your clusters, and it will be handling the routes to the remote clusters. So installing Submariner on your cluster will have no impact on your intra-cluster traffic. That is already handled by the local network plugin, and the traffic which is destined to remote clusters will be tunneled through the gateway node. Something important is that the source IP of the client pod will be preserved, unless we are using GlobalNet with overlapping insiders, and then in that case we need to do SNAT and translation, because it's simply impossible. Cross-cluster traffic, as I said, is encrypted with IPsec by default, and We also provide support for overlapping insiders in your clusters if you enable global net during deployment. Now I will be explaining how service discovery happens. Submariner implements via the Lighthouse subproject the multi-cluster services API. The multi-cluster services API describes a cluster set as a group of clusters with a high degree of mutual trust that share services between them. The idea between a cluster set is that all namespaces with a given name are considered to be the same for the set of clusters. So if you have a namespace with specific name in cluster A and the same name in cluster B, from the point of view of service discovery, both of them are the same namespace. So this API introduces the concept of service export. Service export is what we use to define that a specific service that is running on a cluster or multiple clusters has to be exported to the other participating clusters. So on this slide, I will be explaining how service discovery works with Lighthouse in detail. The Lighthouse solution is made of two main parts. One is the Lighthouse agent, and the other one is the Lighthouse DNS plugin for core DNS. So the Lighthouse agent is responsible for synchronizing back and forth the exported services to and from the broker. It will create imported services locally on the cluster, and that can be found by the Lighthouse DNS. Then the Lighthouse DNS plugin will be responsible for resolving any DNS queries. So we go to the main DNS service of the cluster, and we add an entry saying that any service cluster set local request has to be solved by our DNS server, and then that DNS server will resolve that locally. Also, the Lighthouse agent watches the connectivity to other clusters, and if that connectivity is down for any reason, then it will stop announcing the IP addresses of those remote clusters. So if you have a service which is available on multiple clusters, only the clusters which are connected will be provided as IP addresses. So if you have a service which is living on multiple clusters, only the connected clusters will be in the DNS response provided by Lighthouse DNS. So this is all about service discovery, and now a small description about And now I want to talk about Subcattle. Subcattle is our command line utility to make deployment, verification, and maintenance of Submariner as easy as possible. You can do that also through the operator, but if you want a command line tool, yeah, this is really helpful. So with just 3 lines, you can connect a couple of clusters. The first line creates a broker into, in this case, cluster 1. This broker is nothing more than a namespace living on cluster 1, a namespace and a set of custom resources that the other clusters will use. Also, it has the credentials for the clusters that we will connect later. So yeah, they will be using the API of this cluster. I want to talk about Subcattle. Subcattle is our command line utility to make deployment, verification, and maintenance of Submariner as easy as possible. You can do that also through the operator, but if you want a command line tool, yeah, this is really helpful. So with just 3 lines, you can connect a couple of clusters. The first line creates a broker into, in this case, cluster 1. This broker is nothing more than a namespace living on cluster 1, a namespace and a set of custom resources that the other clusters will use. Also, it has the credentials for the clusters that we will connect later. So yeah, they will be using the API of this cluster. And then, yeah, you can join any cluster with subcattle join. And yeah, it's pretty simple. I will show it in the demo in a few minutes. About our future plan. So what about our future plans for Submariner? Our future plans include network policy support across clusters. This is something that it's still being defined on the multi-cluster SIG upstream, but we have a pretty decent idea about how to implement something like this. We want to support non-IP table network plugins, starting by OPN, and we will make the architecture modular, so any other network plugins can be integrated with Submariner. We want to work on more tunnel encapsulation options, like no encryption if you don't want the overhead of encryption, multipath forwarding, so you could have multiple active Submariner gateways. At this point in time, we are doing active passive, so you have a level of high availability, but yeah, you will always have few seconds of downtime if one of your gateway nodes is down for some reason. We want to work on the broker resiliency. What happens if your broker is down? Ideally, with the Submariner architecture, we should be able to have no downtime in the data plane connectivity or the service discovery. Of course, discovery of new clusters or new services will not work while a broker is down. But yeah, we want to look at that broker resiliency, and at some point, broker high availability, so you could have multiple brokers or any other architecture that provides the same functionality. We want to work on finer grained connectivity policies. Today we do full mesh of clusters, but we want to allow more precise configurations where maybe some clusters connect to a specific cluster, but not all the clusters. Like something like what I was showing at the start. We want to improve the scalability of global net. So if you have clusters with overlapping IP addresses, scalability won't be an issue. We want to test with multi-cluster Istio on top of Submariner. We know that it is possible, but we didn't have time to test it yet. And we have many other open things. We need to work on upgrades to make this we will be working on the upgrade history, so we can have a guarantee that upgrading from one Submariner version to the next is not going to generate any data plane downtime or any other kind of issue. So that was about the future, but what have we been working on the previous releases? So we started bringing service discovery and global net support. Then at some point we removed dependency that we have on the QFET project, and that dependency isn't there anymore. So deployment is a little bit simpler. And we added support for additional cable drivers like WireGuard. Then we added a new IPsec cable driver with Libres1 and some verification commands in subcattle. For the 0.5 release, we synchronized our API with the Kubernetes multi-cluster services API, and now we implement service import, service, and service export. And the latest release, probably, yeah, when you see this presentation, it will be 0.7, but for the 0.6 release, we have been working on support for headless services and basic metrics, some bug fixes, and support for Kubernetes 1.17. And yeah, finally, time for the demo. Wish me luck. Okay, and finally, time for the demo. So let's get into the demo. We have 3 clusters, 2 with OpenShift on AWS and another one with Rancher on DigitalOcean. You can see the consoles here for the clusters. I have also signed up the OpenShift clusters to the cluster explorer that we can see the resources there later. So at this point, what I'm going to do is download the subcattle utility from Submariner. This will help us inspect Submariner and deploy it. First, once we have this utility, I'm going to the first OpenShift cluster, and I will deploy the broker. The broker is just a namespace with a few custom resources available. So if we go now here to the first OpenShift cluster, we will find the broker namespace available. It should be down here, yeah. So this is the Submariner broker. It doesn't have any pod, any service, just a few service accounts and the namespace. So once the broker is ready, we can go and join this cluster into Submariner. We will be using this broker info Submariner file that the broker deployment created. It has all the necessary information to connect any cluster to Submariner, and we'll be doing the same thing with this other OpenShift cluster and also connecting the Rancher in DigitalOcean deployment. So at this point, if we go to any of the clusters, this is the first OpenShift cluster. So if I open the Submariner operator, namespace, we will see all the pods. So we have one route agent per worker node, the Submariner operator orchestrating the deployment and configuration, and then the Lighthouse agent and core DNS, as well as the gateway, which is running on the gateway. We can see the same thing here on the OpenShift dashboard. Yeah, so we have all this running. Yeah, the memory footprint, as you can see, is very low. CPU usage is really small. So at this point we can go, for example, and create a pod, a NetShoot pod on every cluster. Okay, I'm going to choose this. To show you how the connectivity is working at this point. So we can open this one. And another one here. I will use this worker. So now we have a pod running on every cluster through those consoles. We can see the IP address of this one, IP address of this one, and the IP address of this one. I can ping from this one to, for example, this one, and it should work. And the same thing to this other one. Yeah, that was not possible without Submariner, and it is possible now because we have like a big flat network with routing. And the same thing, if I try to ping from this to the other pod, it should work as well. And yeah, it's working. So this is a pretty simple example. Let's go into something a little bit more complicated. Let's deploy a small API service on this OpenShift cluster here on the top right. Okay, we have created this service. We are exposing it with we created the deployment, sorry, and we have now exposed the deployment as a service. Okay, we have our service here, and now I'm going to expose it with subctl, which basically creates a service export. We can do kubectl get service export, and yeah, it is there. So this is published to the broker, and then all the other clusters will be able to discover this service via DNS. For example, if I go to this one on the left, yeah, it is discovering the IP address of the service, which, if you see, it's this one. We can do the same thing on the Rancher cluster. Oops, wait, we need to get into the NetShoot console inside a pod, otherwise, yeah, that doesn't work. So we can discover it here also. We can make a request via curl and it will work. Okay, so and we can also make a request here and it should work equally well. But now imagine that we want a little bit more complex scenario. We want to create the same service in this cluster from Rancher in DigitalOcean. So we are creating the service, exposing it, and exporting the service. At this point, the broker has 2 service exports, and any cluster that will be trying to consume this service will get both clusters in round robin, as you can see here. So we try to run curl. We will be getting responses from pods in both clusters. So we can probably go here. If we go to the broker, no, we cannot see that here. So some other things that I can show you, for example, we have the subcatel show commands, so you can see the connections from this cluster to other clusters, or you can see it also from the point of view of a different cluster. If you want, you can do subcatel get so connections, and we will see it from the point of view of this cluster. So this cluster is connected to cluster A and the DigitalOcean from Rancher. And we can see the IP addresses available on those clusters. We can even run more complicated things like a benchmark between two clusters. We can see latency or throughput. So let's go with throughput from OCP-A to Rancher on DigitalOcean, and this will run a network benchmark from one cluster to another. We can probably see it, yeah. Okay, so let's talk a little bit about the Submariner community. We are an open community and we welcome new ideas and enhancements. You can join us in the following mailing list. We also have a channel on the Kubernetes Slack, so please feel free to ping us there for help or ideas. And if you want to try Submariner, please go to submariner.io. You have a pretty good website with a lot of kickstarts, examples, documentation about how things work. You have our GitHub if you want to look at the source code or contribute. We have a YouTube channel where you can see multiple demos, our Twitter, and the Slack channel on the Kubernetes space. So thank you very much for joining me for this presentation. I hope you enjoyed it, and yep, try Submariner.